In this video, we'll be learning how to simplify expressions that contain radicals and rational exponents, but this time we're going to look at how we do that when we are adding and subtracting like radicals and rational exponents. So in order for us to add and subtract both radicals and rational exponents that are the same, what we need to know is we need to know that radicals with the same root number and radicand. So what I mean by that is radicals that contain the same number outside of the root or the same index and the same number underneath the root. Those are considered like radicals. So notice for this example that this one contains both a 3 in the index of the root and then it contains a 7 underneath the root. And that tells us that these are like radicals and they can be combined like we would like terms. So for example, this is saying these can be combined like we would have 5x minus 12x. It's pretty much the same general idea. So here if we have 5 third roots of 7 minus 12 third roots of 7, we would simplify that and take, okay, 5 minus 12, or we subtract the coefficients here, and we would get negative 7 cubed roots of 7. So we combine them just as we would like terms if we're using addition and subtraction. Now if we look at this next example here, what you'll also notice is while we have a rational exponent, we know that this rational exponent really represents the square root of 8. So what this is really saying is that we have 4 square roots of 8 plus 9 square roots of 8. And because of that, we know that we can combine these like terms. And as a result, if we combine, so we add the coefficients here, 4 and 9 becomes 13 square roots of 8. If you want to write it like the problem originally was, you can write this as 13 in parentheses 8 to the power of 1/2. But again, if we have like radicals, these will be combined together like terms. Now what's tricky about this is sometimes we can't actually see if we can combine radicals right off the bat. So if you look here, these look like all different radicals. They do not look like radicals. We see 2/4 roots, but we see 112 and 7. And then we see 2 powers of 2/3, but we see a 9 and a 72. So what that's telling us is that we need to do a little bit more here. We need to basically simplify these roots using what we know about simplifying roots before we can check and see if we can combine any of these together. So what I notice is that this one right here is completely simplified. I can't make that any smaller because there's no fourth root besides 1 that is smaller than 7. However, if I look at 112, there are a couple of fourth roots I can test with 112. I can test 2 to the power of 4, which is 16, and I can test 3 to the power of 4, which is 81. And if I start dividing these out, what I find is that 16 can go into 112 nicely. So here I'm going to write this as 3 fourth root of 16. And then I find that 16 times 7 is what gives me 112. So I would split this into the fourth root of 7 as well. Now, as I simplify this, these are going to become like radicals. So we know that the fourth root of 16 is 2. So this becomes 3 times 2 fourth root of 7 minus the fourth root of 7. And for this one, we do not need to include the plus or minus because we're simplifying the root and the goal is to find like roots. So for these, you do not need the plus or minus like you do for the other types of problems. And then here we have 3 times 2, which becomes 6 fourth roots of 7 minus the fourth root of 7. So now at this point, all we need to do is combine our like roots. So here I notice that the coefficient of this root is 6 minus the coefficient of this root is 1 because it's an implied 1 out in front. So 6 minus 1 is 5. So I have 5 fourth roots of 7 as my final answer. So if I look at the second problem here, again, I notice that I have addition or subtraction with things that contain either a root or a rational exponent. And because there's addition or subtraction, I'm going to need to be looking for like radicals. Without like radicals, I can't combine things together further. Now what I'm going to do to start here is I'm going to convert these into roots. So I know the denominator is my root, so I have 3 and then 9. Then I have minus, 8, and then the third root of 72. So I start by turning these into roots. Then from here what I'm going to do is I'm going to simplify these as much as I can. So I try to think of all of the powers of 3. So I have 2 to the third power, which is 8, 3 to the third power, which is 27, 4 to the third power, which is 64, and then 5 to the third power, which is 125, which is bigger than 72. So I'm going to use these to help me simplify. Now I notice that 9 is not divisible by any of these numbers, and as a result can't be simplified further. However, 72 is in fact divisible by 8, because 8 times 9 gives me 72. So I'm going to simplify this a little bit. So the first one I'm going to leave alone. The second one I'm going to turn into the third root of 8 times the third root of 9. And now I know that the third root of 8 is 2. So that's going to become minus 8 times 2 times the third root of 9, which then, as I simplify this, I find that I have like roots. I have the third root of 9 paired with both of these, and as a result, I can combine their coefficients. 5 and negative 16 become negative 11, and then I have the third root of 9. So I again combine them together just like terms. So this last problem here looks a little bit complicated, but we're actually going to use our knowledge of roots to help us simplify this as well. So we notice here that we have a mixture of fractional exponents and roots. And to start, we need to get them into the same type. So I'm going to start here by changing this 80 into a root. So I know that the 4 goes into the index. So I have 4 root 80. I'm going to put the 3 on the outside minus, I have 4 root 405 with a 3 on the outside. So now these at least look similar. And I'm going to start by simplifying the root. So I notice here that these are both fourth roots. So I need to think of the fourth roots that are smaller than these numbers. So I know that 2 to the fourth is 16. I know that 3 to the fourth is 81. I know that 4 to the fourth is 256. And I know 5 to the fourth is 625. So I don't have a lot of options for what I can try to divide these by. And if I try to divide them out, what I find is that 80 is divisible by 16, and 405 is divisible by 81. So I'm going to be using a different fourth root for each of them, but it's not going to change the fact that I'm looking for like roots. So here I'm going to rewrite 80 as the fourth root of 80 can be represented by 16 times 5. So I'm going to do the fourth root of 16 and the fourth root of 5 minus, this becomes the, if I divide 405 by 81, that becomes the fourth root of 81 times the fourth root of 5, because 81 times 5 gives me 405. Then I put all of that inside the cubed. So that is where I start. Then from here I evaluate the roots that I can. So the fourth root of 16 is 2. So I have 2 fourth roots of 5 all inside that cubed. Minus, here the fourth root of 81 is 3. So I have 3 fourth roots of 5 inside of this cubed. Now, because it is just one term, so it's 2 fourth roots of 5 and 3 fourth roots of 5 inside of those parentheses, this root of 3 is going to be applied to each of these, technically. So this can be rewritten as 2 cubed, and then this can stay the 4th root of 5 to the power of 3, minus this becomes 3 cubed times the 4th root of 5, also cubed. So now if I simplify this, I end up with 8, and then I have the 4th root of 5 cubed, minus this becomes 27, the 4th root of 5 cubed. Now if you don't like having your root written in this way, we can actually put it back into the fractional exponents and just combined like fractional exponents, because that works just like combining like radicals. So you can rewrite it in this way as 8 times 5 to the power of 3/4 minus 27 times 5 to the power of 3/4. Remember that this really just represents a radical. It's just we're writing it with a fractional exponent. So if we have a like fractional exponent, we also have a like radical. So here what we can do is we can combine our coefficients. So this becomes 8, this becomes negative 27. If we combine those together, we end up with negative 19 times 5 to the power of 3/4. Now if you do like to keep the radicals in the problem, you could also leave this as negative 19 and then have your root of 4th root of 5 to the power of 3. Either of these will work because they really represent the exact same thing. So we can see that even when we have different representations to start, we can still use this same concept of like radicals in order to combine these and simplify them using addition and subtraction.